And then what you need to do is same way, set up D1, set up D2, and set up the call price. And again, I think we had 75, 75, 25, and this was 5%. Each one of these required a formula, so you would just go into D1 and you would say, yes. So, making sure that you get the formulas right here is the main point. D1, it's worthwhile to probably put a parentheses around the whole numerator and the whole denominator. So, natural log of stock minus divided by strike plus the risk-free rate, the volatility squared divided by 2 times the time. And in this case, it's just a 1, but let's just say times down here. And D2 is easy enough to figure out. D2 is equal to D1 minus volatility times the square root of time and then we put in the call value. So the call value is equal to the stock times, now that ND1 in the formula is the norms dist. And all this tells us is that under a standard log normal distribution, how many standard deviations away is D1, this value, minus the strike times the exponential. And here we have square root times time times norms dist of D2. In this case, it doesn't matter. It's just times time.
Why?
In this case, it doesn't matter because it's a 1.
Oh.
So, what we can see is we end up with $5.78.
Can you show the formula again?
Yep. So again, you could put in names in here if you wanted to, but basically it's the stock times the normal distribution of D1. And there was a coincidence that I put these in cells D1 and D2, but it worked out. Minus the strike times the exponential function of the risk-free rate over time times the norms dist of D2. Now, if we look at norms dist, there's a couple of nice things about this. Norms dist of D1 gives us the hedge ratio. So some things that you're going to have to do here, what I would set up is I would create stock prices, 5, 10, $5 increments from, let's say, 5 to 130. Ought to be good enough. Now, I'm going to create a D1 for every different price. And so the things that I don't want to change, the only thing that I actually want to change, given the strike of 75, I don't want to change the strike. I don't want to change the volatility. I don't want to change the risk-free rate. And I don't want to change the time. The only thing that I want to change here is the stop. So instead of using the stock at 75, I'm going to use one that's way out of the money. Now what you can see is I'm left of 0, meaning I'm 2.62 standard deviations to the left, and we know that this only happens about 1% of the time. And you'd be able to drag and drop this, creating a D1 for every value. You'd be able to calculate a D2 for every value. Again, we don't want these to change. So, D1 here, we want to change to our new D1, and we don't want the other cells to change, so we're going to lock those. And again, we could just come up here and copy our formula. And we could calculate a call price for every stock price. Now, what do we want to change in here? D1, we want to change. D1, we want to change. The strike, we want to keep. The risk-free rate we want to keep, time we want to keep, and D2 we want to change. Now, if we get a negative value, we know that this shouldn't be the case. So one thing that we can do is we can say equals the max of this or 0. Let's see if I've done this right. We get basically a strictly increasing function. So if we graph this, our X value, as we've been working with, is our stock price, and our Y value is our call value. And what we can see is kind of this shape that we're familiar with at this point. Yeah?
Can I see that formula for a B, that negative 2.6?
Yep. Oh, and there's actually something I don't think I've done.
Are you sure? Yeah, this should be.
I needed to correct by this, right?
You know better than I do. I guess.
And we should change everything. Divided by volatility times square root of time. And this will change everything. So what happens when we don't lock? There we go. A little bit of a smoother curve. Need to change this one up here also, divided by volatility times know that delta is the slope of this graph, and we can kind of see that this is 0 along here, and then it's increasing, and then increases close to 1. We could also graph the delta, so you would want to know the hedge ratio, right, or the delta, and this is equal to norms dist of D1, and this value as a number, even if we take it out, is 0. And we should get up to close to about 1. If we graph these against the stock price, our X values are the stock price, and our Y values are our deltas. What we see is delta's basically flat. It starts increasing at an increasing rate, and then gets to a point of inflection where it then starts increasing at a decreasing rate, reaching a
Steady state.
maximum of about 1. That's more or less the whole project. There's a couple of just small questions that need to be answered here and there. And that's it for today.
Better.